In this presentation, we will talk about the benefits of cloud deployment using continuous integration and continuous deployment. Just to kick off, let's just go through the agenda. So first we'll look at the local deployment, which in my eyes, or for our use case, means that it's the situation in which you are running the application locally. Then we will look at cloud deployment without continuous integration or continuous deployment. This is essentially similar concept, but you are actually deploying something to the cloud. You're not hosting it in your machine. It's not local anymore. It's all public. And then we'll jump to continuous integration and deployment concept. We'll speak about the benefits of using it, the process, and the machines that are involved in that process. And then we'll just wrap up. So let's first talk about the local deployment and what is it. As mentioned, this is a scenario where you're running your application on your laptop or your PC without deploying it to the cloud or any external machine. This is all isolated on your machine. In this situation, your computer acts as a code base repo, a build and release agent, and a host machine which runs the application. In terms of how it would look like on the amazing graph, apologies for my graphing skills, it will be something like that, where your PC is that main square and it contains all those elements. Maybe build agent should also be release agent here as well. And then just to sort of give you an idea of what those mean, codebase repo is your code on your machine. This is a screenshot of a solution explorer in the Visual Studio. You can see the Azure Functions application in a solution with a class library with the logic layer. So this is exactly the concept that it's pretty simple. Then next, we have a build and release agent, and that GIF shows the process of rebuilding the application. This is also Visual Studio, and then you have a little window with a folder. You can see that the obj and the bin folders are being generated automatically during the build. Those are getting regenerated every single time. This is the process of building the application. And finally, the last step here, which is the host machine, and that is also your computer in that regard. If you recognize, this is Azure Functions window. This is how it looks like when it runs, and this is all happening on your machine. You can also see that there are some functions triggered on the HTTP request, and they are reacting to, or they're listening to, port 7071 on the local host. This is your server that is spun up by a .NET SDK on your machine. So now we understand what the local deployment is. We can sort of weigh pros and cons of this. Definitely, this is a very fast process. There is no fancy pipelines attached. You run it in your isolated environment, which leads us to the next point, which means it's great for development purposes. You have full control over environment and cache and all that nonsense. And also, it's very easy to attach a debugger. There is a possibility of attaching debugger to the remote processes in the cloud, but that's not in the scope of this course. It's obviously much easier to get debugger attached in your local environment. And then some cons: your machine has to stay on of all times with the internet access most of the time, depending on obviously what the application does. That puts your machine under a lot of stress, running multiple servers. Generally, this is not suitable for production environment. Your development machine is your development machine. Your production code should not live on your development machine. So next, let's go through cloud deployment without using continuous integration or deployment. So for our purpose, this is a situation when you decide to deploy your application manually to an external machine, but without using automated pipelines. So this can be deployed directly from your machine, like Visual Studio, or a pipeline in the cloud, but without automated triggers. Let me explain that in a bit more detail. So this is an example of Visual Studio deployment where you can publish the application simply by right-clicking on it and press publish. This will publish the application with some basic configuration that you can provide to an existing app service in Azure. I don't think you can create an app service from here, but I may be mistaken. You can leave the comment down below if you think that's possible. Another example of this would be a deployment from CLI. So in this situation, this is Azure CLI deploying a container, an Azure instance. This is also happening from your local machine, or you can do it from Azure Cloud Shell. The idea here is that this is not automated. You have to manually trigger that pipeline to run. And then last example would be the pipeline that is written in YAML, which, by the way, if not all, then a lot of pipelines are written in YAML. You can also create the sort of visual representation of it using Azure pipelines, which you will see later. But this is an example of an on-cloud pipeline, but without the continuous integration and deployment. So this will run again only if I trigger it somehow. This particular one is triggered based on tags that I push to the repository. That's out of scope of this tutorial, but just so you have a better idea of how this is getting triggered. So now we understand what those use cases are. Let's just look at the pros and cons of this sort of deployment. So when we're delegating hosting task to an external server, like on cloud or on-prem, that's good because it takes away the need of keeping your development machine constantly on. It takes the sort of the load of running it off it as well, which means that you separate your tasks in that manner. If the pipeline is in the repository, like there is a YAML file, just like on GitHub, for example, or you have a pipeline built in Azure Pipelines or Azure Releases, it provides a centralized point of build and deployment. And what does that mean? Well, it means that when anyone deploys the application from that place, you know what's been run. You know the configuration of the pipeline because you can read it. Everyone's got access. All the team members have access to that pipeline. So you can see what's been changed, if anything has been changed in the configuration, and you know what's run. As opposed to, and that leads us to a first con, if you deploy, and by you mean yourself and your other team members, from your local machine, this can create problems because your configuration of your deployment, someone else's configuration, how they deploy to the same app service, doesn't necessarily mean that they're the same. So if they differ, then this will cause issues, and then you don't have a build and release audit. You can't see the history of deployments. You don't know when and what was deployed, and you don't know who deployed it. And then lastly, it requires manual input to trigger pipelines, which essentially means that in order to release an application, a small update, one character change, you have to push your changes to the remote repository or just to deploy from your own machine, but you do it manually. There is no triggers, if you will. Maybe that will make more sense when we get to the continuous integration and continuous deployment, which we will now. So before we start, let's just think about what is required or desired from the deployment process. You want to know what is being deployed. You want to know when it is being deployed, how it is being deployed, and if it's getting deployed at all. Let's just go through those one by one. So by what? I mean, you make some changes to your code base. Instead of deploying directly from your machine, you push those changes to the remote repository, because you can then create a pull request. Someone else can look at the code and see the changes that are made. But not only that, even if you're working on this by yourself, after you deploy, you can then see what changes you've made. Perhaps you broke something, but you will know exactly what this is if you commit your code often and you make clear comments on what you're doing. So the what can be achieved by using pull requests and code review process. Next one is the when. So why do you want to control when you deploy? When you think about it, maybe you have a backend application that runs on timer trigger every day at 9, and then there's another job that runs every day at 10, and then another job that runs every hour. So with that knowledge, you can have some sort of logic that creates retries in your code, but generally, let's just say that you don't want to terminate your processes. They deleted some data from data warehouse and they didn't insert the new data yet, and you end up having empty tables now because you've just deleted the data, but you terminated the job halfway through because you've just deployed the application with downtime. Another example would be when you have a client-facing website and you have peak times, 5:30 p.m., a lot of users historically on your website. This is not the great time to deploy the application unless it's something major. Obviously, there are ways to prevent or minimize downtime, like using staging. But let's just say that these pre-deployment conditions here, called the gates, allow you to specify the order in which these applications are being deployed. In this case, there is no time constraint, but the Azure Functions stage has to wait for the web app to be deployed first. This might not make sense here because those are completely separate from each other, but this is how I designed it in the past, and that's just how it stayed. It's not crucial to the process, but it actually illustrates how those can be used. Then you can control how you deploy your applications. And this is the idea that I introduced earlier, where you have a centralized pipeline in the cloud. So in this case, in Azure DevOps pipelines, but also it can be a YAML file in your repository. This way, the configuration is set in stone, which means that it's there for everyone to use. And other team members don't just go and deploy it from their own computers with the configuration that they think is right. And then lastly, we have the if. And that just means you're using code review process in which you reject the changes that are not right, or you can just provide feedback and you spot a bug, you provide that feedback, you don't approve it until this is corrected and the right changes are pushed. And then, and only then, you approve the changes, and the developer that raised that pull request can then complete the pull request and the merge. So lastly, or finally, we can now move on to continuous integration and deployment and think about what these are. So these are the definitions. That's a bit of terminology here for you. We read that continuous integration is a step in which all code is merged as developers complete code in order to run automated builds and tests. And then the deployment is the process of moving software that has been built and tested successfully into production. So immediately what should strike you here is that the integration is more to do with the code itself being merged into build, and the deployment is more about taking that build software and moving it into production, which in our case could be, for example, moving it moving it onto the host machine into app service where it runs. So moving on, we'll see the graphical representation of the continuous integration and continuous deployment structure. What's striking, first of all, is that your PC is only a local repository at this point. It doesn't do anything else. All the other tasks are delegated to the cloud. And the cloud, as you can see here, consists of 4 different squares, and each of these squares will represent another virtual machine. And this all happens in the cloud. You'll also notice that each of these are labeled. They will have Azure DevOps, GitHub, and Azure Portal. This is just the example I'm giving here, but obviously it's not bound to those services. Azure DevOps will have Azure pipelines and Azure releases. GitHub will have GitHub actions and workflows. And I don't know what are equivalents in AWS or GCP, but I'm sure there are some. So we will go through those machines one by one. But just to give you a sort of high-level overview of what's happening here, is that your local repository, which is your code on your machine, you make changes to a new branch that you derived from master branch, for example, or test branch. You then create a pull request when you push that branch to the remote repository to the test branch. So you have a new branch that you create a pull request to merge into test. Someone reviews that code, this change has been accepted, and someone completes that pull request. The pull request will trigger a build agent. This is continuous integration. The build agent builds the application, compiles the code, and drops the artifact, which is a sort of packed compiled code. When this package is dropped in a location that is specified, the release agent gets notified about this. That is a new version of artifact available, which is a new version of your compiled application. And that triggers, guess what? Continuous deployment pipeline. The release agent then takes that packed code, runs the release pipeline, and pushes changes to the host machine, which runs the application. So that's the high-level overview. Let's go through them one by one. So let's start with which machines are involved. You've got local repository, remote repository, build agent, release agent, and a host machine. It's 5 virtual machines involved. Firstly, the remote repository. I will ignore the local one because we've already shown that before. This is going to be this example of your Solution Explorer with your code base on your computer. So you've got Azure DevOps here with master branch and the repos tab. You create your pull request using the pull requests option in the menu, and someone reviews it and then pushes the changes. When the branch that you push to has a continuous integration enabled, which is the bottom screenshot here, this one here, you specify the branch of dev. For example, you push that change to dev. If this is ticked for dev, this pipeline will get triggered, and you might see it on the top that there is a triggers tab. This is where this bottom menu is. So this pipeline will run. That will build your application, and then the last step you see here is a publish artifact drop. This will take the build application and place it on a drop location. Okay, so this is continuous integration in a nutshell. Then, when the new artifact is available, the release pipeline, which is just in the releases under pipelines in Azure DevOps, and you have this option here selected, so continuous deployment trigger, you specify the build, which is the dev build in this situation. When the release pipeline sees the new version of that artifact, it will automatically trigger this pipeline to run. And then, once this is done, this deploys the application to the host machine. And in here, this is an example of just how can you see the some advanced tools and the actual sort of inside and file system of that machine in Process Explorer. This is just processes running, and this is PowerShell console. You can use command prompt as well to investigate that file system and see how the application is actually built. But the host machine is the machine behind the app service. So to wrap it up, let's go through pros and cons of continuous integration and continuous deployment. First of all, you have a one-time setup. So you set your pipeline once and it's there, saved. You can run your release, your deployment as many times as you want. This is directly related to the only con that I could really find, and that is more work to be done when setting up. Because in some cases, especially with small projects, publishing it from Visual Studio or from the command line is just very easy, and maybe only thing that's needed. But this obviously depends on the project. I don't really find a use case for deploying this way, as I just like things to be done properly, quote unquote properly. So a second pro is centralized pipelines. So you have full control over what, when, how, and if things are being deployed. That's not strictly CI and CD, but I just find this to be an integral part of that process. You have full audit trail of previous commits, builds, and releases. So you can see exactly what commit triggered what build number, and then you can see which build number triggered which release. So there is a full audit trail. You can trace things back. You know what's been deployed and when and how, and that's pretty important. And then this is an automated process, which means that you only worry about the source control, and deployment takes care of itself. So when you look at the process again, you will notice that we only push the changes to the remote repository, create that pull request. That's still within the source control part of things, really. And when the changes are approved and your changes are pushed to the persistent branch like test or master, then you don't care about the deployment or build, because this process is automated and triggered automatically based on the new changes on the branch. So you can be sure that the code that runs in the cloud is now a reflection of that branch that is triggered on. So all in all, I think this concept of continuous integration and continuous deployment is really important, and I find it very useful, and I think that it should be utilized as much as possible. Okay, that's it for today. I really hope you enjoyed the video and you've learned something today. Have a good day and Happy New Year. I'll see you next time.